Now we will see the conversion of the Moore machine to Mealy machine algorithm. First, the input. Input is the Moore machine and the output we get a Mealy machine. Step 1. Take a blank Mealy machine transaction table format. Step 2. Copy all the Moore machine transaction state into this table. Step 3. Check the present state and their corresponding output in the Moore machine state table. If the state QI output is M, copy it into the output column of the Mealy machine state table wherever QI appears in the. Do not worry, we will get a better look in the example. Here, let's consider the following Moore machine. The step 1 was take a blank Mealy machine transaction table. Okay, this is the question. We will understand this table firstly. On this is the present state, this is the next state, and this is the output. On giving the input A equals to 0 and on giving the input A equals to 1. So firstly the state is A, that is the starting of the initial state. On giving the input 0 on A, we will move to D at giving the output 1. Same like on giving the input 1 on the state A, we will move to state B on giving the output 1. The same for full table. Now the step 1 and the step 2. Now we will apply the algorithm to convert the Mealy machine to Moore machine. So firstly, as in the step it was written that take the blank Mealy machine transaction table format. So this is the transaction table of the Mealy machine. Now we have the written as same. Copy all the Moore machine transaction state into the table format. So from here we have copied all the next states to our Mealy machine table. Now we will see the step number 3. Check the present state and their corresponding output in the Moore machine state table. If the state QI output is M, copy into the output column of the Mealy machine state table wherever QI appears in the next. Here is the step 3. So here we have done a simple thing. You can see from these tables. A, when we give the input 0, on A, when we give the input 0, it's give the output 1 and moves to the state D. Same here, when we give input 0 to the state A, it moves to the state D on giving us the output 1. Same continues for all. Like this, when we give the input 1 on the state A, it moves from A to B on giving the output 1. So same here, A on giving the input 1 moves to B on giving. Once again we will see, on giving the input 1 on to A, we will move to state B on giving the output 0, and we see that the output of the B is 0, that this output which we are getting here, we can clearly see from here. A output is 1, B output is 0, C output is 0, D output is 1. Simply we have written here the same. A output, D output 1, A on B output 0, D1, D1, A1, A1, D1. So we can see the similarity C0, B0, and here also the C is 0 and the B is 0. We have just copied that. Now we will understand how to convert a Mealy machine to a Moore machine algorithm. Input Mealy machine, output Moore machine. Step 1. Calculate the number of different outputs for each state Qi that are available in the state table of a Mealy machine. Step 2. If all the output of Qi are same, copy the state Qi. If it has n distinct output, break Qi into an state as Qin, where n is equals to 0, 1, 2 and so on. Q3. Step 3. If the output of the initial state is 1, insert a new initial state at the beginning which gives us the output. Firstly, we will check here the output related to the states. Firstly, we will check for A. A gives the output 1 here and also 1 here. Okay, so we'll do nothing with it. Now we will see the B. B is giving output 0 here and B is giving output 1 here. So we have to break it in the two states. Same for C. C gives the output 1 here and the output 0 here. So we also have to break C, and D is giving the output 0 and D is giving the output 0 here. So we have nothing to do with this. So we have seen that A will remain same, B will divided in the state 0 and B0 and B1, and C will also divide in the state C0 and the C1, and D will be. Now we will see the answer for this. So as I have said, the B is divided into the two states B0 and B1. Same, C0 is divided into C0 and C1, and A and D remains the same. Now we have seen that on giving the input 0, A goes to D, and on giving the input 1, A goes to B1. Same we have written here, and output related to A is 1. So we have written A1 and A1, A1 and A1. So we have written here the output 1. Same for B0, B0 or simply. So for B0, we can see on giving the input 0 on B, we will go to the state A, and on giving the input 1 on state B, we will go on the state D. So here we return both the same, but on giving the B0 state, we will get the output 0, and on the state B1 we will get the output 1. Now C0 and the C1. On the state C, when we give the input 0, then we move to C and giving the output 1, and when we give the input 1 on the state C, then we move to the state C0. So we have written the same here, C1 and C0, C1 and C0, and the output related to the C0 is 0 and the output related to C1. Now we will see what going on with the D. On giving the input 0 to the D, we will get the output 0, and we will move from D to B, or simply say we can say we will move to B0, and on giving the input 1 on the state D, we will move to state A, getting the output 1. Same we have written here, B0 and A on, and the output related to D we can see from here, D0 and D0. So we have written here the D output is 0. Thanks for watching my video.